quadratic equation. We said yesterday, if there is a coefficient here, then we can forget about trial and error. So we have learned to practice. Now we have practiced to learn the formula. It looks vicious, I must admit, but not when we start looking for the pattern. The mind is a pattern making and a pattern using system. So when you look at this, the mind cannot absorb pure data. This is just like a traffic jam. So we have to see, we have to find a way to remember it. We have to see if there is something, if there a way to remember all this. So I told you we do that in 3 steps. So we already knew that looks like a fraction. So we start, we have to go from x squared to x. So it's not difficult to see that something on something. A very difficult numerator and just an ordinary numerator, denominator. This gives the name. So we can start x and we start this line. We can start, not think, oh, I forgot, no. We can start straight away. We see this. We know that we can't do trial and error, so we start x line. X line. Repeat. X line. This is the X line. And now we're going to see if we can see something familiar. Well, we have to go from x squared to x, so we know that there is a square root symbol. X line square root symbol. X line square root symbol. Let's see what goes underneath. There's a way to remember it. Twice this one. Touch it. Twice this one. 2a. Ah. This is a specific. But the general one that uses the 3 letters, we have to call this A, we call this B, not take away 3 now, B is -3, and C is -3, A, B, C. Now that cannot be difficult, except that we include B is -3. Okay, so we have to use A, B, C. X line, 2 of those. That's a good start. Aha! We see 3 negatives. So we start X line, 2 of those. Opposite of this is this. So that's a good start. And then 1, 2, 3. If you start with this one, then the other two are complaining. If you start with the last one, these two are complaining. So we start with the middle. This is already there. So B is negative 3. So that becomes positive 3. We know that it is when there is an even index, we have two possibilities. We have already this, so negative 2 times negative 2 is 4, but positive 2 times is also 4. So square two answers. The 2, 2. As soon as you see the 2, we know positive and negative. Now outside that is B, so it's not so silly that it's inside it's B squared. So we have this, we have this, we have this, we have this, we have this. Now we have to now try to remember this, a little trick again. Two of those. That's 4. Two of those. Two of those. That's 4A. There's only one letter to go. That's the C. I do this again. You practice that on a piece of paper. X. Line. Two of those. Opposite of square is square root. Your 3 negatives. You start with the middle. That is B. We have x squared, x to the 4, two possibilities. This is a single B, inside it is B squared. This is already there. And then our I goes twice this one. So that's 4A. We have used the A and the B, so now we use the C as well. There's not a soul in this world you go to school, but nobody tells you how to remember it. Not for the last 200 years. Learn this family, learn this formula. Don't forget. Well, of course you forget. Professional memory training. I want to remember. Second question, how can I remember? That's why we can do maths in minutes. General form. We don't know yet, we don't know yet, we don't know. So ABC is not difficult. In this case, the A is now 2. The B is negative 3. And the C is negative 7. Now, if you can't do that now, well, you better go to sleep. It's better that I introduce this first. We are now concentrating on this part, and we can find out if there is an X, if there are two X's, if there are two equal, or if there is no possibility. And this tells you whether that is the case. Now it is not strange that we have called this part the discriminant. This part discriminates between two different ones, two equal or no x. The discriminant. So I'm now taking that discriminant all by itself. I feel like a market salesman selling flowers. The discriminant, and we call that not a triangle, yes, it is a triangle, but it is the Greek capital D. Alpha, beta, gamma, D. Delta. D for D. Delta. The discriminant. It discriminates. Okay? It discriminates. It shows whether this quadratic equation has two different real roots, two equal real roots, or no roots at all. Roots, the answers are called the roots. Not strange, because it is the result of using a square root. So the answers are called roots. If delta is positive, then we have two different roots. If this part is naught, we have two equal roots. And if this part is negative, there are no roots, there are no answers. No real roots. The discriminant. It discriminates. The discriminant is actually only the bit under the square root symbol. So forget about this. So we have to see whether this quadratic equation has two different ones, two the same, or there is no answer. Okay. B squared is negative 10 squared is 100. Negative, positive, positive, so it's 100. Negative 12 times 8 is 96. And the square root of 4 is 2. So we put that in the formula. So we have negative 10 positive 2 or negative 10 negative 2, and then divided by 2a. Divide by 6. B squared is 36. Negative, positive, positive, so that is negative. A is 1, C that's 9, but it is 4ac, so there's 4 9s is 36. So this whole thing is naught. So the answer is negative b positive naught and negative b negative naught. So there are two equal answers. Let's do this one. B squared is 1. Negative is positive, negative is negative, so that is negative. Well, 4 2s is 8, times 5 is 40, so that is a negative number. In other words, there are no answers. Later we can see actually right now. So, 2 answers, 2 the same or no answers. And that actually can be shown in a graph. But to do that, we are going to go through the 3 steps. Not the 3 steps, the 3 situations. This is a quadratic expression. You can only factorize it. Remember, positive 5 and negative 3. Because the product is negative 15 and the positive is divided by 2. So we can only factorize this. Now it becomes a quadratic equation. So it's positive 5 and negative 3. The answers are the opposite, negative 5 and positive 3. So this has 2 answers. Factorize. Work out the x's. And the third possibility, instead of calling it naught, we calling it y. So all of a sudden, like drawing a straight line, we have an x and we have a line, we have a y. And if we say x is naught, then the y is negative 15. X is naught, the y is negative 15. And that is going to be shaped like a parabola. So the vertex, that is the lowest point, is negative 15. And it cuts through the x, and it keeps on going, and it cuts to the x. So it's negative, it's naught, and it's positive. So we don't know, it can be depending on where you are in the parabola. Parabola. This is called, so y is x squared positive 1. The number in front of the x squared is a positive coefficient. That's very important. If this is positive, then the parabolas are these shapes. Concave up. And it has no roots. That means the discriminant, so we talk again about discriminant. is negative, there are no discriminant is naught, so the two roots fall together. And if the discriminant is positive, then we have two roots. And if we go, the average of negative 2 and positive 2 is naught. And if we put that, so this one belongs to this one. If x is naught, y is negative 4. So that is called the vertex. These are the coordinates. X is naught, y is negative 4. Y is x-ray. This is what we call the standard parabola. The two roots are the same. If x is naught, the y is 1 up. So this never cuts here. So there are no roots, but there is still a parabola. So if x is naught, y is 1. And they go sort of symmetrical. If x is 1, y is 2. When x is 2, y is 5. And of course, you don't have to do that side. You just measure this and this. So you only do one side. If x is naught, y is naught. If x is 1, y is 1. If x is 2, y is 2. Y is 4. If x is naught, y is negative 4. If x is 2, then y is naught. That's the root. If x is negative 2, that is 4 take 4 is also naught. So x is naught, y is negative 4. X is negative 2, y is naught. X is positive 2, y is naught. Now, with a line we can do with three things. Now here we only have this point, the vertex, minimum, and this point. So, we have to put quite a number. So we do x is negative 1, x is negative 2, x is, yeah? X, y, x, y. So we have at least, to give an idea, we have to do at least, yeah, only half, because it's symmetrical. So at least 4 or 5 or 6 points. And we have the points. There is a flexi ruler made of rubber. You can buy them at the news agency. So you drape that flexi ruler over the points. I gave mine away, so I haven't got it anymore. So we're talking about the parabola because y equals x squared positive 2 negative 5. Now we know that if x is naught, that can only happen when x is 3 or when x is 5. We did that the first exercise expanding with expressions. So we have the X line, positive 3 on this side and negative 5 on that side. And in between, the negative is winning by 2, you have to halve it, negative 1. So the axis, the one in the middle, the equation of the axis is negative 1. That is in between these 2 points. And if we then, okay, then we have to substitute this negative 1 in here. 1, negative 2 is negative 1. And then the y is negative 16. That is way down. It's a minimum. This is called the vertex. In this case, it's minimum means the lowest point. The roots, the opposite of this, 3 and negative 5. The average of these two numbers is negative 1. You put that in, and you have the y is negative 16. That's called the vertex, the minimum, the lowest point. And this is for tomorrow. So now the coefficient is negative, so the parabola is concave down. The same thick. 2 roots, 1 root, no roots. Positive discriminant. Discriminant is naught. The discriminant is less than naught. The headlight in the car is in the shape of a parabola. And here is a specific point. You know that in a magnifying glass there is certain point, and if you hold it in the sun you can burn leaves. That's called it escapes me. So that point, that's where the lamp is, your light. And it shines on the side of the shape of the lamp, and it goes out straight. The focal point, the focus. So any line hits this straight. That's why you have a headlight, because the light inside is the headlamp is shaped like this. The light is here, shines on here, straight out.